this video we're going to look at the trends for electron affinity. Electron affinity is defined as the change in energy that accompanies the addition of an electron to an atom in the gaseous state. If we were writing out an equation for this, if we take any element x in a gaseous state and add an electron to it, we are going to produce a negative ion of x. So one thing to keep in mind with the trends for electron affinity is we're going to go through them, but they are not as defined as the trends for atomic radius and ionization energy. So don't worry about what the numbers mean in this diagram here, but take a minute to take a look and see if you can see any trends and see what I'm talking about how the trend is not that great. Okay, so we're going to look at the trends for electron affinity as we go down a group. So as we go down a group, electron affinity decreases. The reason being is that electrons are further from the nucleus. Remember that the atomic radius is increasing as we go down a group. And that means the nucleus, which has the positive charge, is not going to attract or, for lack of a better word, want electrons as much. So that means it has less affinity. So as you go down a group, the electron affinity is going to decrease. As you go across a period, electron affinity is going to increase. And the reason for this is because we're closer to filling the valence shell, and so atoms are going to want to have a full valence shell. And the electrons are now closer to the nucleus as we go across our period because the atomic radius is decreasing. So both of these reasons are going to make the atom want to attract another electron. So it gets easier to add that electron as you go across a period.